Hey, how's it going? My name is Josh Garrick. Today I'm going over some topics in Chemistry 1310, specifically the ideal gas law, as well as mole fractions and partial pressures. So, first, just an overview of what the two really are. Here we have, let's see, the ideal gas law, which is equal to pressure times volume equals number of moles times the gas constant times temperature. So PV equals nRT right over here. We have that rewritten a couple ways. I mean, it can be derived in many different fashions to suit however you need, whatever you need to solve for. But just another note, we have the ideal gas constant, which is a constant which is equal to 0.082057 liter atoms per mole Kelvin, and that's at constant pressure, volume, and temperature, while it's also equal to 8.3145 joules per mole Kelvin, just another form of that, depending on what units you're working with. And then over here we have mole fractions and partial pressures. So mole fraction, which is just a concentration of a component in a mixture, is defined as the number of moles of the component that are in the mixture divided by the total number of moles present. So mole fraction of A equals XA, so that value is equal to the number of moles of A over the number of moles total. And the partial pressure then would be that mole fraction times the total pressure. So then we're just going to go through two practice problems using both of those concepts. So our first one's going with the ideal gas laws. So the question says a sample of CO2 gas, carbon dioxide gas, has a volume of 575 centimeters cubed at 752 torr and 72 degrees Fahrenheit. What is the mass of carbon dioxide in the sample? So the first thing we have to do is change all of our different things to the right units. So we have 72 degrees Fahrenheit. We're going to convert that to Kelvin by going through these steps as seen. We have 752 torr is the pressure. Divide that by 760 torr, which is equal to 1 atmosphere, and you're going to get 0.990 atmospheres. And then our volume is 575 centimeters cubed, so 1 liter is equal to 1,000 of those, and we're going to divide that and get 0.575 liters. So to get the number of moles, we're going to take PV equals nRT and rearrange it to N equals PV over RT. Using our values that we just calculated, as well as the ideal gas constant, which is for those units, we're going to set this up 0.990 times 575 divided by 0.082 times 295, and that's going to cancel everything out, and we're going to be left with 0.0235 moles of carbon dioxide. Then to find out how many grams are in the sample, which is the mass, we're going to take that times the molar mass of CO2 divided by 1 mole, which is the molar mass, so 44 grams, and we're going to get 1.03 grams of CO2, which would be left in the sample, which is the mass of carbon dioxide in the sample, which is what the question was asking for. So that's just one example using the ideal gas law. There's many different ways you can use it and many different things you can do with it, but it's useful when we're doing different calculations in chemistry. So going on to our next practice problem, we're going to be calculating mole fractions and partial pressures. So as the question states, we have a solid hydrocarbon which is burned in air in a closed container, and it produces a mixture of gases which have a total pressure of 3.34 atmospheres. Analysis of the mixture shows it contains 0.34 grams of water vapor, 0.74 grams of carbon dioxide, 0.288 grams of oxygen, 3.790 grams of nitrogen, and no other gases in the container. The question is asking us to calculate the mole fraction and partial pressure of carbon dioxide in this mixture. Okay, so we know that our number of moles total is going to equal a number of moles of H2O plus CO2 plus O2 plus N2. So we have that set up as the what we're given, the number of grams divided by the molar mass of all of the 4 of those. Add those all together to get the mole fraction, and we're going to have 0. Yeah, 0.1809 to then get our well, that was the number of moles total, actually. I'm sorry, I'm mistaken. But next we're calculating the mole fraction, which is the number of moles of CO2 over the number of moles total, which is 0.018 over 0.1809. This is actually a unitless number. Mole fraction doesn't have a unit, but it's going to be 0.0995. Then we're going to use that to find the partial pressure of carbon dioxide in the container. So we want to take the mole fraction times the pressure total, which was given in the question. It's going to be 0.0995 times 3.34 atmospheres. And in the end, we're going to have 0.332 atmospheres of carbon dioxide in the system. So that was just going over two topics which we've been talking about a lot in lecture and recitation and lab this last week. Hope it helps a little with understanding ideal gas laws and partial pressures and mole fractions. Thanks.